Hey guys, welcome to our video. So today's lesson is about protein synthesis. That protein? No, this protein, which resides within our DNA. You ever wondered how our body makes protein, or how our hereditary genes varies within ourselves, or how we're unique from others? Well, today we're gonna take a look at that, shall we? So this is the human body, stated around to have 46 chromosomes, each half amount coming from their parents. What is a chromosome? Or what is inside a chromosome, you ask? Well, a chromosome is built up of DNA. Surprising, right? Before we dive into the DNA, we must dive into the parts of the cell. So, as you already know, a cell has one basic part. This is called the nucleus. Most processes in protein synthesis occurs in this part. Nucleus doesn't have one, but not two, not three, but a billion DNA strands inside the nucleus. Now, outside the nucleus, there is a part called a ribosome. It is a cloud-shaped form that processes the messenger's RNA to form amino acids and eventually pop out a protein. Protein synthesis is divided into three parts: duplication, in which a DNA duplicates itself;
Are you still using that?
transcription; and lastly, translation. All steps of which contributing to developing proteins in our body. Dying to know the DNA, eh? Well, let's see what the DNA looks like. Zoom in! Welcome to the second part of this video, in which we will be talking about DNAs. Every strand of DNA contains a codon, in which has three parts: phosphate, sugar, and a nucleotide. In the process of making an RNA, a DNA must be zip-tied or separated within its weak hydrogen bonds by an enzyme that cuts it off in half. You might wonder, what is this triangle-shaped thingy? Well, this is an enzyme, all of which take parts importantly in DNA duplication and RNA making. But wait, I'd known these stuff before. They're like construction workers. Well, you are absolutely right. These enzymes command where a nucleotide go, when, and what to put in it. As the enzymes command the builder enzymes on where to put the decided zip-tied RNA, they go around placing hydrogen bonds in between and messages to form the so-called messenger RNA. The developed RNA goes outside the nucleus and heads to the ribosomes to be processed to get an amino acid and continues to develop a protein. Welcome to the third part of this mini-series. So, the last part of the protein synthesis is translation, a process in which occurs that a messenger RNA goes into our ribosomes to be processed with the anticodons, delivering amino acids for forming a chain and developing into a protein. all of which happens in our bodies about 1 billion times, or maybe more, in every second. As the RNA approaches the ribosomes, anticodons check up on it as it gets automatically processed for its corresponding amino acids. As per here, the anticodon does not fit. A second anticodon comes in and grabs the amino acid methionine, and which is inside the ribosome, transfers it to the corresponding codons and starts the chain. So as you can see, the chain of anticodons form the chain of amino acids that is taken from the ribosomes and is now a 4-chain long protein.
Kadol. Yang kadol. Anak dun
Ay,
kadol.
sila din eh.
Ha?
Dili, kani.
Oh. Video mo gugud.
Goodbye, yo.